We have explained that planets are propelled by the rotating gravitational field of the Sun and brought to the precise orbital velocity. The Sun is also indifferently driven by the planet and orbits around it if it rotates sufficiently. For example, the Earth and the Sun run around each other. The speed of orbit of the two can easily be calculated as follows. Then both run around the common point O. This gives the relationship. This relationship proves that the Earth and the Sun do not run around a common center of gravity, as was previously believed, but around the so-called momentary pole, a common zero point of speed. For the common focus, this relationship would be like this. So the previous knowledge that two bodies move around a common center of gravity is wrong. From this example it is also clear that without external force, the paths of two bodies running around each other form round circles. The so-called two-body problem is actually a task from the previous term to calculate the movement of two bodies without additional external influences. Then the real two-body problem can be solved so easily. Without additional external influences, as we can now see, two bodies can never form an elliptical trajectory or something similar. How the orbits of the planets and the Moon originated and what their shapes actually are, we will learn later. But how stable is such a two-body system? In the tangential direction of the Earth's orbit, the driving force F1, which is generated by the solar gravity field, can be determined as follows. In the opposite direction is the Earth's inertial force F2. Both balance each other out. Likewise, the driving force of the Earth's gravity field F5 and the tangential inertia of the Sun F6 balance each other out on the Sun's orbit around the Earth. And the gravitational pull of the Sun to the Earth F3 in turn raises the centrifugal force of the Earth F4 too. Conversely, the gravitational pull of the Earth to the Sun F7 does this with the centrifugal force of the Sun F8. In addition, the centrifugal forces of the Earth and the Sun are equally strong. The gravitations of the Earth and Sun are also the same. Now the Sun-Earth system, if it is not disturbed from the outside, is in full dynamic equilibrium. This is a system so perfect that it can be untrue. It is a miracle of nature. Such a perfect system actually has to exist before a stable system can even exist. There is also a planet that does not rotate or almost does not rotate. For such a constellation only the planet revolves around the Sun. When the Sun does not orbit the planet, it lacks a centrifugal force F8, which offsets the centrifugal force F4 of the planet. This also causes the system to lose its balance. Could it still be balanced? As shown in the sketch, the Sun drives the planet to run counterclockwise, and as a result, the planet orbits the Sun. It does not rotate, but with its own gravitational field it also pulls the Sun in the same direction. Similar to a rotary motor effect, this is a process similar to a type of linear motor, the technology of which is used, for example, in magnetic levitation trains. This effect causes a common revolving around a momentary pole O, which lies outside the connecting line between the two bodies. As explained, the inertia or the centrifugal force always counteracts the acting force, regardless of the form of movement. This acting force is the gravity of the planet. So the centrifugal force of the Sun is directed towards point O, the red arrow. The speed of the Sun was caused by the gravitational field of the planet and then corresponds to the speed of the planet around the Sun can be calculated quite normally. So the Sun and the planet revolve together around the point O with the same angular velocity in relation to point O. The ratio of velocity and radius is also the same as follows. Hence, this construction is thus also in full dynamic equilibrium. But for such a system to run forever, both bodies, like the example for the Sun and Earth, must have sufficient rotational force to overcome mutual gravitational field resistance. But where are these powers supposed to come from? And because the gravitational fields are there forever, the rotational forces, on the other hand, have to work forever, for which energy is required. This is not just about any large portion of energy. This requires energy sources that can possibly generate an astronomical amount of energy per second. Without the energies and these forces, however, the perfect system would tip over. We'll find out how nature solves these problems in the next videos. Thank you very much for your attention. See you next time.